All right, now we are going to do the last section in the chapter. It's called Other Solar System Objects. So this is essentially all the other stuff that is not the planets. First of all, we cannot talk about this without talking about Pluto. Now, Pluto is what is now classified as what we call a dwarf planet. When I grew up and I went to school, Pluto was a planet. With the advances in technology and the advances in being able to see beyond things in our solar system, we started to discover many other things. We just started discovering other objects that were similar to Pluto. So then you ask yourself, okay, if I'm going to call Pluto a planet, then this object that's pretty close to it, very similar, I better call it a planet. I better call this a planet. I better call this a planet. So when you start doing that, you have to kind of draw a line in the sand somewhere to say, no, we're going to say this is a planet and this is a dwarf planet. Otherwise, our solar system goes from having 9 planets to 30 planets, which obviously isn't, easy for us to decide. So dwarf planets are celestial bodies resembling a small planet, but they lack certain technical criteria that are required for it to be classified as such. So planets must have, or in order for something to be a planet, it has to orbit the sun. It has to not be a moon. It has to have a round shape, so enough gravity that it pulled it into a round shape. And finally, it has to clear its orbit of debris. And that was the last one that Pluto did not have the ability to check off in the criteria box. Pluto did not clear its orbit of debris. So that is why Pluto is what we classify as a dwarf planet. It's our most recently discovered planet, putting it in quotes there, discovered in 1930. Actually by a farmer. His name was Clyde Tombaugh. He loved making telescopes out of things in his garage, and he actually discovered it, which was pretty cool. Named after the Roman god of the underworld. So we're thinking, when you think mythological speaking wise, the underworld, so that's, bad place. Really cool side facts of it is Pluto's moons are actually named also mythologically after things from the underworld. So Charon, its largest moon, which shockingly rotates around each other. So Pluto's moons, Charon, one of them, the biggest one, does not rotate around Pluto. They rotate around each other. So imagine like you and your friend are holding hands and you're kind of spinning in a circle. That's how Pluto rotates with Charon, which is also not normal. But Charon was the person that in the underworld, the river Styx actually ferried people across that river Styx. So Pluto, 248 Earth years to rotate around the sun once. Think of that, 248 Earth years. Just to get there, travel time, it would take you 9 years, essentially, with our current technology to get there in a spaceship. That's a long time. Pretty cool, though. It's with our technology, too, we've gotten some really cool pictures of Pluto in the recent 10 years or so here. Just beyond Pluto, kind of in the same general area, is something that we call the Kuiper Belt, and you can see a picture of it on here. The Kuiper Belt is where we get a lot of our comets coming from. It's essentially what we kind of think is after the solar system formed, it was all this sort of debris that was left on the outside of it that just didn't coalesce for whatever reason. The Kuiper Belt stretches to 1,000 AU, so it goes out really, really far. It's believed to contain many asteroid-sized objects and a few Pluto-sized objects. Asteroid belt found in between Mars and Jupiter contains a majority of asteroids in our solar system. So asteroids are objects that orbit the sun, but they're too small to be considered a planet. So they're not going to have enough gravity to pull themselves into that spherical shape. The largest asteroid, named Ceres, is 933 kilometers across. And you've probably heard of asteroids before when we talk about them in science and the dinosaurs going extinct 65 million years ago because we believe an asteroid hit Earth, crashed into Earth around the area of Mexico, and essentially had such massive impacts that it killed off a good portion of the dinosaurs that were living on Earth at the time. Comets are space debris made of rock, ice, dust, and metals, so they're similar to asteroids. The difference is they contain ice. So they're made of rock, dust, and metals. Now think of the fact that they contain ice. So what's going to happen if you're made of ice and you go near the sun? You are going to melt because the sun is hot. As you can see in the top picture up here, what happens is as that comet draws near to the sun, the tail starts forming, and you'll notice in the picture on the top, the tail is always going to point away from the sun. It makes sense because that solar radiation is going to heat that up and cause it to sort of eject from the back of the comet. Comets do revolve around the sun, so just like planets revolve around the sun, comets revolve around the sun, but they have what we call highly elliptical orbits. So is where the planet's orbits are elliptical, but they're hard for us to kind of see that they're actually elliptical. They still look circular. Comets are highly elliptical, so they would really look, if you want to use a non-scientific term here, really egg-shaped as they move around the sun. They have very distinct parts to them. The inner core of the comet is what we call the nucleus, as you can see in the middle there. And as I just said, as the comet gets closer to the sun, it forms a tail. So if you want to just draw this picture, that would be great, just so we just kind of get the major parts of the comet in. So we have the nucleus, that's the biggest part of it. And you're going to have the tail coming off of it. The coma is actually the part surrounding the nucleus, that as it's melting, it's sort of like this cloud of dust and gas surrounding the nucleus. And then we have two different tails. We have the dust tail, which is primarily debris, and then we have the ion tail, which comes from some of the interactions with the gases of the sun. Meteoroids, space debris larger than a piece of dust, but smaller than an asteroid. So they're orbiting in space. So a meteoroid is orbiting in space. They're not as big as asteroids. They're going to be smaller than that. Meteors. If a meteoroid comes into Earth's atmosphere, and if it is falling through Earth's atmosphere, we call it a meteor. Or to us, we call them shooting stars. So you can say now, instead of, oh, I see a shooting star, you can say, oh, I saw a meteor. When things fall through Earth's atmosphere and gravity's pulling them down at a really high rate, that can cause these things to burn up, essentially. And as they burn up, that's what you're seeing in the sky. Most meteors are not very large. Most meteors are actually really quite small. Now, if they are big enough to survive that entire passage through Earth's atmosphere and they land on Earth's surface, we then call them meteorites. So a meteor that has survived passing through Earth's atmosphere and landed on the ground is a meteorite. Usually not very big. Think about what most of the surface of the Earth is covered with water, so a lot of these fall into the ocean. However, if you're on a quest to find meteorites, the greatest places on Earth to find them is where there's a lot of snow, because it's dark and because you're not going to have things growing up in that area. So a great place to find these are places like way northern Canada, Antarctica, places like that. You're going to find those. So meteoroids in space, meteors are shooting stars in the atmosphere, meteorites land on Earth's surface. As Earth orbits the sun, it passes through debris and will sometimes pass through a lot of meteors or a meteor going through, and then we get what is called a meteor shower, which is essentially all these bits of dust that are burning up in our atmosphere. Most meteor showers occur between August and December, and they happen on an annual basis, so they happen every single year, because just like we travel around the sun every year, the other space debris is orbiting the sun on an annual basis. One of the most famous meteor showers I put on the slide here, the Perseid meteor shower, this year on the mornings of August 11th through the 13th, it's going to be at its peak, and you can actually see about 40 to 50 of them per hour. So think about that, being outside and having the ability to see that many per hour. Yeah, so that's meteor showers. All right, so now we know the difference between all of those things, between asteroids and comets and meteors and meteoroids and meteorites.